Hi, it's a continuation of the previous video. Now here I'm going to discuss about the situation or the condition for an object to topple over. Now what is the condition for it to topple over? You need to again know the center of gravity of the particular system, and then you will draw the line of contact with the ground. I repeat, so you need to know these 2 points. One is the center of gravity of the particular system, and the point that is in contact with the ground. From the point you can draw a perpendicular line. So these two, if you know, then you will be able to make the judgment, right? Now here I've taken a rectangular block. Now say this is the point of contact, so your line of contact will be the perpendicular. This should be perpendicular to the surface, right? I've drawn the line. Now where would if it is a regularly shaped object, then it's going to be somewhere in the middle. That will be your center of gravity. So what's the condition for this to topple over this side is when this point crosses the line of contact. Crosses means it goes to the other side, then it will topple to the other side. If not, it will come back to this position unless there is any other force that is holding it. You get it? So if you're pushing an object, when will it go to the other side? Once the center of gravity crosses the line of contact. So before making the judgment, as I said, you have to find these two, center of mass and the line of action through, or the line of contact through the ground. Now there is a question which we'll see. One question here. Now I've just drawn or represented the values given in the question. This is like a wardrobe that's being pushed, or a person is trying to push it, but at this position it is in equilibrium, right? Now it is held in equilibrium at this position, so there is a force. Person is standing here. I've not drawn the person. The person is applying a force P at this angle, and this angle is 30 degrees. Okay, these are the information given to you. The mass of the wardrobe is 40 kg, and the distance that the person applies the force is at 1.6 meters from this pivot position. So this is the point of contact here. That's your pivot position, and 1.6 meters, and that's it's at right angles to this distance. Force P is applied. Now this is center of gravity. This point is the center of gravity. You can see the weight is acting down, and this is the point of contact, right? Now the distance between the center of gravity and this line, or the line of contact with the ground, is 12 centimeters. So these are all the information given to you, and the question is find the value of P. So how will you approach this question? One, I've told you first the center of gravity is already given to you, so you don't have to bother. But second, I told you pivot position is right there. Third, I told you about the perpendicular. You have to check whether the force and the distance are perpendicular to each other, right? Now here, if you look at, yes, this is acting at an angle. The force is acting at an angle. But if you look at the distance from the pivot, this is 1.6 centimeter, right? Now the question itself, it says these two are perpendicular to each other. So the force and the distance are perpendicular to each other, so I can directly apply it. I don't have to find the component here. Keep it in mind. So you don't think only if it is vertical and horizontal we need to apply. Otherwise, if it is at any angle, you have to resolve it. That's not the case, right? If the distance and the force are at 90 degrees from the pivot, then you can use it. This is one tip I'm telling you. Please keep it in mind. All right. Now, so from the pivot, this is acting in this direction. So that's your clockwise moment or clockwise force. Now this is to the left, so this is your weight is on your anti-clockwise direction. So from the pivot, if you look, this is going to the right, this is pulling it this way, this is clockwise, and this is anti-clockwise, right? Now how do I frame the equation then? So your clockwise moment will be P multiplied by 1.6 meters would be equal to W. This is straightforward because a similar question was asked in mock, where you have taken the entire distance, the line of action and the force must be perpendicular to each other. Don't take this entire distance. that's not correct. The distance from the pivot. So here you can see these two are perpendicular to each other, right? The force and the distance must be perpendicular to each other. Okay, so 12 centimeter would be 0.12 meters, right? Now W 40 multiplied by 9.81 you can do and get the value of P. You get it? So this is how we approach this question. There was one more question which was asked. It says, now if you want you can try this out and check the value. You should be getting 29 newtons. Alright. Now for part B, they had asked you, determine the value of the upward force N of the floor on the corner of the base, which is like the reaction force from here. What is this force equal to? Now, see, sometimes you will arrive at an easier answer if the other forces are known to you. Why? If it is in equilibrium, I repeat, if it is in equilibrium, the total upward force must be equal to the total downward force, correct? Or the resultant force must be equal to 0 in an equilibrium. So here, if you look at it, W is the force acting down and the reaction force is acting up. Any other force acting, P is acting at an angle. P is acting at an angle. So if you resolve it, you have one component horizontal and one component vertical. So a vertical component of P, which is acting up, plus this N should be equal to W. I hope you got that. So looking at all the forces that is acting here. So why didn't we consider this reaction force in our calculation here? In the previous video I told you, if there is any force acting through the pivot point, the moment due to that force will be 0. So you don't have to consider that. Alright? Okay, now here when you are applying the forces, so we have W acting down, W must be equal to the reaction force N plus the vertical component of P. Right? Now if you are using that, this will be 30, so it will be P sine theta. Right? This will be 30 degrees. So W will be equal to N plus P sine theta. You can apply and find N is equal to, I think answer you will get is 380 newtons. I hope you're getting it clear. Now there was one more question. Explain why the wardrobe will topple into a stable position when the delivery or the person pushes it past the point where the center of gravity is vertically above the corner of the base. Now, what would you write when the line of action of the weight is at the right of the pivot? There will be a resultant clockwise movement. See, I told you before, if it is shifted to the right, if the point comes to the right of the line of action, you will have a resultant moment acting on this side, which will make it topple over to that side. If it was here, the resultant moment is here. If there is no force acting on it, it will go to that side. So keep that key term in mind. If it is passing the center of gravity position, the resultant moment acts to the right hand side of the line of action. Hence, it will topple over. Right? I hope this is clear. Please keep this in mind when you are solving questions. See you in another video. Bye.